Today we're going to be working on the concepts of osmosis and diffusion. These are passive transport mechanisms that are used by the cell to move materials back and forth. And we're going to work with diffusion by putting a drop or two of methylene blue, which is a dye, in this first beaker. And you can see how the material is kind of concentrated in one location, or relatively concentrated toward the bottom of the beaker. I will actually rotate that very slightly so that you can see that better. The thing is, it is not uniformly distributed throughout the water. And what we expect to happen with diffusion is that over time, the dye will go from an area of higher concentration, as we see it now, to areas of lower concentration, and we will end up with a relatively uniform distribution of the dye throughout the water over the course of the next hour or so. Now, obviously, you don't have to watch it for the entire hour. We're going to record some of this, and then we'll go ahead and jump to the end. The other concept that we're looking at is osmosis, which is the movement of water. And water moves when solutes, like the methylene blue, cannot move. And we're going to do this experiment with a potato, or a chunk of potato. And we're going to put one chunk in very plain water, and we're going to put the other in some very salty water. And I'm going to salt this water up right now. So it'll take a moment or two of stirring to get that to distribute. But what we are doing is we are making a hypotonic solution relative to the potato, and hypotonic means that there is less stuff dissolved in the solution than in the potato, and a hypertonic solution, which is the one that's going to have all the salt in it, which has a higher concentration of stuff in the water than in the potato itself. Or that's the theory anyway. The way that we're going to be able to tell if there has been any change over time, if there's been any movement of water either in or out of the potato chunk, is by taking its weight. As if it has gained water, it will gain weight. If it loses water, it will lose weight. And I think that that is probably as well distributed as we can get. You can see that the water is very murky, cloudy, with the amount of salt that's located in it. So now we're going to cut up a potato. So we're just going to need a few small chunks off of this potato. So I'm going to cut the end off here. And cut it into, really looking to get two pieces out of this that don't have any peel on them. So we'll toss these others away. And we've got one chunk here. We'll split it in two. And now we have two chunks of potato that we can work with. So the first chunk of potato that we have labeled potato A, right now we see that the weight is 0, and hopefully you can see this. It is now 6 grams. So that piece of potato weighs 6 grams. That piece of potato is going to go into the plain water. For potato B, let's tear that. Okay, and piece of potato B, we get a weight of that. And that is, again, if you can see it, it is 5.47 grams. So we're going to take that and we're going to put it in the very salty water over here. And we're going to let that set for about an hour and see if there's any change that occurs, if any movement of water occurs going in or out of those potato chunks. One thing we can see right away that tells us there is a difference in the density of the fluids is that the chunk of potato in beaker B, the one that has the salty water, that is the one that is hypertonic to the potato, is the potato is actually floating, and that's because the water is denser than the potato is, or the water with the salt is denser than the potato is. Well, it's been about 45 minutes now, and as you can see, the methylene blue has spread pretty much evenly throughout that beaker. We have reached a state we call equilibrium, where everything is in balance, so I doubt that there will be much more spread, and this is just a byproduct of a passive process called diffusion, where things go from higher concentration to lower concentration. I have a presentation that covers this and osmosis, which I urge you to listen to because it really explains these concepts much better than I'm able to in just this short period of time on this experiment. We are going to take a look now at the potatoes, and we're going to first look at the chunk that was in beaker A. That was the one that was in plain water. We're going to try that off a little bit. And let's get a weight on it. The previous weight was 6.0. Whoop. Now, you can see it's 6.11. So we have gained water weight in the potato that was in the hypotonic solution. Now let's take a look at the potato in the hypertonic solution. And this is potato B, which has now sunk to the bottom. Let's take that out. Take the bulk of the water off of it. And we're looking at this. You can see it's zeroed out. We've put the potato in there. And now that potato weighs 5.10 grams, down from the 5.47 grams that it initially weighed. So in the potato chunk that was in the hypertonic solution, we have lost water. That concludes our exercise on osmosis and diffusion. If you found that informative. The data that you collected from this in the form of weights that were from the potatoes at the beginning and at the end of the exercise, you will record on your data sheets. You will submit that in the online. So thank you very much.